Do you notice the difference between radical expressions and radical equations? Expressions can be simplified, whereas equations can be solved. We can actually get what is the value of that variable. A radical equation is when the variable is beneath that radical sign, because you'll notice it is equal to a certain value. It is equal to a certain value. So we can actually figure out what is the value, or what are the values of x that make the left side of that equation equal to the right side of that equation. An expression does not have that second side to the equation, so we can't say what x is equal to. All we can do is simplify. There are steps that we can follow in order to ultimately get the solution of that variable, beginning with stating the restrictions on the variable. There's a previous lesson that we already did on how to state the restrictions on a radical, so we're just briefly going to review this. You can always go back if you need a more thorough explanation. Remember, if it's a square root, we only have restrictions if we have an even index. So in both of these cases, we have an even index. We are going to set that radicand so that it is either positive or equal to 0. And then our goal is to isolate that variable. So I'm going to begin by subtracting 5 from each side. So that's going to give us -5 on the right. I'm then going to divide out this -1 in order to isolate x. And remember, every time we divide or multiply by a negative, we are flipping that inequality. So that's going to now become x must be less than or equal to 5. And you can always put a number back in here to make sure that this radicand is positive anytime x is equal to 5 or less than 5. So same thing over here. We're only concerned about the variable in the radicand. This whole expression has to be greater than or equal to 0. And then again, our goal is to isolate the variable. So in this case, we're going to isolate n by subtracting 8 from each side, which gives us a restriction of n must be greater than or equal to -8. The last two, practicing by stating the restriction, you'll notice neither of these are radical equations. These are both radical expressions. And again, we have square roots. So I need to say what is the value or values of y that will make this radicand 0 or positive. So I'm not even worried about anything else. I'm just going to take that radicand. We're going to set it greater than or equal to 0, and then we're going to isolate y. So we're going to begin by removing any piece that we are adding or subtracting. We're then going to remove anything that we are multiplying or dividing. In this case, we're going to divide out the 6. 6 divided by 6 leaves 1y. So y is greater than or equal to 5, 6. And again, you can always put values back in here to test to make sure that this is correct. Now in this one here, we have two radicals in the expression. So we have to do two restrictions. So I'm going to take this first radical in the numerator, set it greater than or equal to 0. This one in the denominator, now because it's in the denominator, remember t cannot equal 0 because that's going to make the whole denominator 0. We cannot divide by 0. So you'll see here we just have 3t must be greater than 0, not equal to 0. And again, we're going to isolate the variable. Now we need to choose the restriction that satisfies both. So if you go onto your number line, take a look. T must be less than or equal to 4. So that's going to be here all the way to -infinity. Or t must be greater than 0. So I've got my open circle, so it's not equal to 0, but it's all values greater than 0. So we're looking for where those double arrows occur, because any number within here, if we substitute it back, it's going to make this positive or 0, and it's going to make this positive, which is the goal. So my restriction in this case is going to be t must be greater than 0, and t must be less than or equal to 4. So if t is between those values or equal to 4, then it's going to make this positive or 0, and it's going to make this radicand positive. All right, let's now take some equations and see if we can solve them. So we're going to go through the steps, beginning with number 1. So we're going to state the restrictions. So we're going to see this is a square root. What are the values of x that will make that radicand positive or 0? So in this case, x, set it greater than or equal to 0, and it is already isolated. So that is the restriction. Number 2, isolate the radical. So that means is anything else on the same side of that equal sign as the radical. So you'll see that this one is already isolated, as opposed to something like this, where this is our radical. This -2 is not underneath that radical sign. So we would have to move this over, first of all, in order to isolate that radical. This one is already isolated. Now, we need to get rid of this square root, and so the opposite operation to square rooting is to square. And anytime we do something to one side, we're going to do the same thing to the other side to keep it balanced. That's kind of like Algebra 101. So we're going to go ahead and square both sides, and then we know that squaring essentially cancels a square root, leaving us just with what we have underneath the radicand, which is x. x. So in this case, we have x equals 25. We have nothing more to solve. That is the solution. But we now need to check for extraneous roots. Extraneous roots are roots that are mathematically correct. We did everything correctly, but they don't satisfy that original equation. So if we were to substitute this back in, we would not get the left side equaling the right side. There's two things we can look at here. So number one, check the restriction. So we know that x has to be greater than or equal to 0. 25 is greater than or equal to 0. So that part's good. Now we're going to actually substitute this back in to make sure the left side equals the right side. It's really important in algebra that you always do that. Typically, you do it just to check to make sure you didn't make a mistake in your work, but now you have to check because you could have the correct solution, but when you put it back in, the left side and right side are not equal, in which case we have what we call an extraneous solution. So we need to verify this. We're going to take the value of that variable and we're going to substitute it back in the place of that variable, and then we're just going to go ahead and work this out. So the square root of 25 is 5. 5 equals 5, so the left side equals the right side. So we know this is good. That means this is a good solution. So this particular equation has one solution to it. Now this one over here, again, I'm going to go through the process. So we're going to begin by stating the restrictions. This is my only radicand here. So x just has to be greater than or equal to 0. Now in order to isolate the radical, so this is the radical, we want that by itself. So I'm going to bring this to 0 by adding 2 to each side. I now have that radical isolated. We're going to square both sides in order to eliminate that square root. So when we square a square root, that's basically gone. And then on the right-hand side, we now have 4. We don't need to solve this because we just have x equal to that value, but we do need to verify. So we're going to say, okay, if x is 4, we're going to put the 4 back in here. We're going to write out the rest of the equation, and then we're going to check. So the square root of 4 is 2. 2 minus 2 is 0. 0 is equal to 0. So the left side equals the right side. So that tells us that this is the correct solution. We have one solution to this equation. In this next example, we have two radicals, so we have to state the restriction on each of these variables in the radicand. So I'm going to begin by just saying, okay, this first one, x minus 1, that has to be greater than or equal to 0. The second one, 2x plus 3, that also has to be greater than or equal to 0. Isolate each of those variables, and then we need to see which of those values is going to satisfy all conditions. So it helps if you can draw out a number line to visualize this. So our first restriction, x must be greater than or equal to 1. So x can be equal than 1 or any value greater than 1. X can be equal to negative 3/2 or any value greater than that. So we want the double arrow here because we know if we choose this one, then it will satisfy all conditions. If we happen to choose this one, then we could potentially put in, let's say, negative 3/2 here, minus 1, that's going to give us a negative value. So that's not okay. So the restriction that satisfies all conditions is going to be that x must be greater than or equal to 1, and x is an element of the real numbers. Step 2 is isolate the radical, and you can see that this one radical is isolated on the left, this other radical is isolated on the right. So in this case, we do have each of those isolated. Step 3, we're going to square both sides. So I'm going to square the whole left-hand side, I'm going to square the whole right-hand side, and we know that when we square, it's going to cancel out that square root, leaving us just with that radicand underneath. We now have a linear equation. So if this is a linear equation, our goal is to isolate the variable. So because I have two x's, I'm going to move them to one side, and we generally move over the smaller one just so we can avoid any negative leading coefficients. And then at the same time, if I'm going to isolate x, so I'm going to move my x's over here, I'm going to move this 3 over here. So I'm going to subtract 3 from that side and then subtract 3 from that side to keep it balanced. So we end up with x is equal to negative 4. After solving for the variable, here's where it's crucial to check for extraneous roots. If you go back to the restriction, we can see that x has to be greater than or equal to 1. Well, negative 4 is not obviously equal to 1, but it's also not greater than 1. So because this is not greater than 1, we say we have an extraneous root. So there is no solution to this, and negative 4 is a correct solution mathematically, but this is not going to be a solution to that particular equation. And you can see when we substitute it back in, we end up here with -4 minus 1 under that radical on the left, which is -5. We cannot square root a negative number, and so because that is not possible, we just have no solution for that particular question. In our next one here, you can see that we now have a cube root. So in order to do the restriction, because it's a cube root, we can have a negative radicand. We just have to say that that variable has to be a real number. So now step number 2, we're going to isolate that radical. And so you can see this is the radical. This equal sign is like a barrier. So I want on this side of the equal sign, this is the only thing I want. I need to remove that 12. So I'm going to bring that to 0 by subtracting 12 from each side. And then 15 minus 12 is 3. And then once we have the radical isolated, now in this case, because it's a cube root, we're not going to be squaring because that's not going to get rid of a cube root. What will get rid of the cubed root is to cube that side. So we're going to cube each of these sides here, and then cubing is going to cancel out the cubed root, leaving us just with that radicand. 3 cubed is going to be 27. And now again, we have a linear equation. So our goal, isolate the variable. We're going to begin by removing anything we are adding or subtracting. We're basically doing bedmass in reverse. So we're going to add 11 to both sides. And then we're going to get rid of that 2 by dividing it out. And when we divide that out, 38 divided by 2 is 19. And then again, n just has to be a real number. 19 is the real number, but we need to substitute it back in. So we're going to put 19 back into this equation in the place of n, and then we're going to go ahead and work that out to check, does the left side ultimately equal the right side? If it does, we have one solution to that question. 19 is the value of n. For the last one here, why don't you pause the video, see if you can do it, and then come back and see if you're correct. All right, so step number 1, state the restriction. So I'm going to take this radicand because it is a square root, and I know that this has to be greater than or equal to 0. So this is a positive number, which means r also has to be positive or it has to be 0. Now, we need to isolate this radical. So again, just like doing order of operations in reverse, I'm going to first remove any piece that we are adding or subtracting. So I'm going to add 14 to both sides, and then I still need to get rid of this 5 that I am multiplying by. So I'm going to divide that out of both sides. 5 divided by 5 is 1, so that's just going to leave us with that radical, which is what we want. Now, in order to get rid of that radical sign, it is a square root, so we are going to square both sides. As soon as we square a radical, it's going to cancel it. We're going to be left with the radicand 3r. 6 squared is just 36. We're going to divide out that 3 to get the r by itself, and r is equal to 12. Now, check that against the restriction. R has to be greater than or equal to 0. So 12 is greater than 0, so that's good. And then we're going to verify this. So we're going to take 12. We're going to substitute it back in the place of that r. And then we're going to work this out to see, does the left side equal the right side? And because it does, that means we have one solution. It is going to be 12.